let's we can get started. Yeah, firstly, I want to quickly make an announcement. There is I mean, this is unrelated to the class, but basically there is a event. It's called, it's the 10th Annual Women in Business Conference, which is happening on March 13th in Student Center East. So it's basically general information. So if you're interested, you should sign up and attend this networking event. It's mostly about celebrating women in business, and also there will be a lot of Chicago area business professionals potentially there. Okay. So that's the general announcement. And if you need some extra information, I just mentioned the event name. It's the Annual Women in Business Conference. If you need more information, just email me. I'll send you the full information. Okay, guys might have already gotten it. Okay. Let's see, what are the people online saying? Oh yeah, there's a question about now. Let me also again repeat something about the logistics. In particular, the logistics about the presentations that are going to happen next couple of weeks. That was a question also raised online. So, in fact, I had notes on that. Exactly, one of the questions is about what is the order and things like that. So let me just mention that. Let's see. Yeah. So firstly, let me first start with presentation logistics and then talk about the project itself. Presentation logistics, there are 2 sessions reserved for this because there are about 15 groups or so. The order of the presentation will be randomized, and so you wouldn't know whether you're presenting next week or the week after. We'll just randomize in using Google Sheets basically at the beginning of the class, and then we'll know who's presenting in the first half, first half of the number of groups. So about 7 groups will present on the first day, and about 7 to 8 groups will present on the next day. And the presentation, so I'll also set up a box folder where you can upload your slides. If you have a PDF or a PPT or equivalent, then you can just upload it there so that it's easy for everybody. I'll just download it onto the machine at the beginning of the session, so we can, we don't have to switch between laptops, and all that complexity goes away. So that's the logistics. So now, with respect to the number of minutes, I will say the exact number of minutes in an announcement when I send you the box link. I don't want to send that out because currently you should be focused on your report and whatever code artifacts, if there are any. Focus on that because that's the thing that is being evaluated. So the box and slides and stuff, they are not evaluation. They're not for evaluation. So, so those are the 2 things that are going to happen. So firstly, focus on your report and code artifacts because the deadline is next Tuesday, basically midnight, before midnight. So that's the deadline for that. And for that, the link will be on Blackboard. The link that I will send through an announcement is a box link just for the slides that you can use to assist in your debrief of what tool you looked at. And the order, again, just to repeat, is going to be randomized. And so we'll just pick some random set of 7 or 8 teams to present on the first day, and the remaining set of teams to present on the next day. Okay. So hopefully that's clear on the logistics of the presentation. So the only thing you need to act on the presentation and the logistics of the presentation is wait for my email or the box upload, as well as the number of minutes for your presentation. It's going to be basically the classroom hours divided by the number of teams with some buffer for switchover and Q&A and so on. Okay, so try not to put too much information in your presentation. It's not really to discuss everything about your tool that you've looked at. It's to give a sense of if somebody else did not work with a tool, but they want a good TLDR, basically. Right. So a short summary of what did you do and whether it's useful in a regular data science workflow, then that's what you want the audience to get out of your talk, your presentation. Okay. So that's about the logistics, about what to include in your slides. So don't include too many materials. Suggestion is at most 5 slides generally, but I'll write these things down in an email announcement I'll send. Okay. And with respect to the project itself, I have been mentioning it a couple of times already. If you have still not yet decided on what project you need to pick, then you should do it ASAP. So all of you have figured out what projects you want to work on, tools. You can always run it by me. The second half of the lecture, anyway, the second half is supposed to be for you to try out the tools that I'm demoing in the class. If you're not simultaneously doing it. So you can always check with me what tool you want to, and several groups have already checked with me before, but for those who have not, you should check it, because it should not be the case that you pick some tool and just discuss it on the last day, and then everybody's how is it relevant to data science or anything like that, right? So you don't want to have a surprise element. So try to focus on the tool 99.9% of the time. The ML project is not so when you think of an ML project, you think of, okay, what is the model family, what is the data set, how do I curate it, and maybe use the tools to kind of get to a dashboard. That's not, I mean, that is still a project, but that's not the project for this course. This course is about focus on one tool, or maybe at most a couple, okay? But really focus on one tool and just talk about how you work with that tool and what the tool's capabilities are. Not your project, not the data prep, not the ML project, whichever domain it is, and all that, okay? We don't need to know those details. Okay, it's just a question of, okay, here's a tool, how hard is it to set up and get going and use it for a particular problem, for a particular types of workflows or tasks you might have. Okay, so really that's I've been mentioning this a couple of times already, but it's really important, just based on previous semesters and so on. So really focus only on the tool. It's going to be, in that sense, it's going to be very different from the other ML projects you might have done in 575 or 576 and other places. Okay. So that's about the projects. Anything else? Okay, there's some question. Do we need to come in person to give our presentation, or can we join remotely? So yeah, this is in person. So the whole class is in person by default. Most of the, I gave you optionally to be, I let people optionally join on Zoom because there are no power plugs here in this room. But yeah, this is in person. So no Zoom by default, I guess. Yeah. Okay. So with that, let's actually get started. This one. Yeah. Yeah. So just, I mean, I want to get a sense of like broader picture, right? We've been doing a lot of tools, and, it's, towards this, like, during the lecture, we get into hairy details of how to get things going, but we have to always zoom out and say, okay, what is it covering? What type of aspect of tasks and stuff that I would learn, which might be useful in a future situation, right? So we are at almost the end of the lecture sessions. And obviously there's a project report submission and with corresponding artifacts, if any. Yeah. Sample report. Okay, so which is there in the project notebook, right? So if you look at the third notebook here, it tells you what you should typically cover, but it's not necessary. So each tool will have its own yeah, because if it's a visualization tool versus a data annotation tool versus a web serving related tool, it could be a cloud, it could be a managed service, and we'll see some managed service details. But there were managed services we already saw, right? Cloud functions and stuff. It's going to be very different, right? You can't download them and run or anything, right? So and any page, yeah, there is, right? So yeah, so you have 8 pages. You can have an appendix for extra material that you cannot, like, generally what I've seen, and okay, there's a good question actually. So generally what I've seen is if there are screenshots, and generally screenshots are helpful for, just documenting at least like what was your flow from A to B to C, because sometimes you don't want to be writing paragraphs here. So, and you also should not be writing too much of the marketing material. That's also not useful. Okay, we don't want to know all the marketing features of this tool, which you can easily get from the copy of their documentation site or the website. It's really about like the quick start would be the closest of what is the tool about, what did you do, for example. The quick start or initial like tutorials, for example, for that tool would really focus on that tool, right? But yeah, there is a page limit, and so extra pages can be used for screenshots and things like that because they do occupy, you know, almost a page or half a page and so on, right? But I would say don't be, so I already gave you some slides and I didn't want to do that because that further biases your thinking, okay, this is how the slide should be, but that's not the case. It's just some couple of student presentations from some previous semesters. They did some job of it, right? It's not like the best or, you know, it's also not bad. They had certain perspective that they wanted to present and they did it. But you can think of your own way of how to kind of discuss about the tool in your presentation, but also in the project. It really depends on what you want to cover. Really, 8 pages is enough because I said don't include marketing material because anybody can read that from the tool's webpage. Also, don't include the ML focus. You know, if you want to include it, just put in a supplementary or additional material. When the first 8 pages, really, it's about, okay, what's the tool? What is the use case you're thinking of, or what's the tool use case that it suggests, and how did you kind of try it out, right? Yeah. So that's the focus here. So I would say reports, I'll probably not share. If you really want it, just send me an email and I'll think about it. You know, we can discuss, but try to use this as a guideline because it also tells you what the evaluation criteria is. Okay. So if you make it easy for the reader, so think of the project report as really, if you are in a team, in a data science team, and there could be many data science teams in a typical organization, unless it's a really small startup or something like that. Okay. So if you write down something, it's just it basically goes into something like a Confluence or a wiki or something like that, where somebody else can say, oh, maybe a year ago or 6 months ago, we did evaluate some tool for some use case. Is it relevant or not? Somebody else would read it. Maybe you yourself will read it after 6 months or a year. So it should kind of capture the key elements of what is it that you're looking for, and does the tool help you do that? Okay. That's what it is. That's what documentation is, right? So that's the objective of the report. It's really not trying to cater to just the professor as audience, but just think of it as a future self or a team member. You just want to quickly clean over within 5 minutes, get a gist of, okay, is this a tool for what they want to do? Okay, that's and same thing with your presentation. Is this a tool that they can see, okay, they've done something in their, everybody here in the audience has their own background in terms of where different companies they've worked in and whatnot. They can always match to what they've seen in this tool can do, what you have investigated versus what they've done in the past or what they can think of in the future. Okay. In the report, can we talk about installation of the tool and then cover multiple applications of the tool? So this really depends on the tool, but installation, if it's small enough, yeah, you can include it in the main section, or you could, if you think that detracts from the discussion, you can put it in the appendix. But appendix part is not evaluated strictly. In a sense, it's there, good to know, but the main information should be in the first 8 pages. Now, multiple applications of the tool, you can even do just one application, doesn't have to be multiple at all. And if needed, if you think multiple applications illustrate the tool better, you can cover that. But don't make it an advertising copy, a marketing copy. That's the other extreme, right? So we want it to be a semi-technical discussion of tool, use case, experience of you trying it out. So it's a little bit different, I mean, than the a little bit more business analytics courses that you've seen, 572 and 575 and so on. But if you have questions, like, I would say definitely reach out to me, because if you have a specific tool that you've already chosen, and by the way, you should put that name in the Google Sheet that we have, where there's a list of members. You should put the tool that you're going to discuss. And also, if there's a link to it, either a proprietary software or if it's an open source software, there should be some link to it, canonical link. You should put that in the Google Sheet. Yeah. So I hope that answers some of the questions. These are questions from the people online. Yeah, and it is in person. I'll send details about the presentation again. So I hope that's clarifies a little bit more. I hope it's not confusing. It is not expected to be confusing. It's not a high pressure thing. It's just an investigation, a journey into the tools landscape around machine learning. And it's going to evolve. The tools that you see today is not going to be there maybe a year or 2 years later. That's okay. but the general patterns and concepts will remain and make you more ready for potentially new tools. Okay, let me come back to the syllabus. Okay, I'll yeah, let me not go over this material. Let me switch to the slides because I'm going to mention where we are at the high level there. Yeah. But yeah, so there is grading. So definitely this is in person presentations next week and the week later. So yeah. So let me jump to the slides. Actually, let me go back here. Yeah, so I wanted to give you a landscape of where we are. We couldn't cover everything, but that's okay. There are actually too many tools to count, and that's why there's the presentations by students for 15 other tools that we probably did not cover in the class. Okay, that's one of the reasons why we have that presentation component. But if you look at the landscape, I mean, this is not the only landscape, some subset of topics, but the first topic was just deploying an ML model, because that's the first thing you would think of once you train a model on Google Colab or on your local Jupyter installation. Once you train a model, logic regression model or some model, you want to kind of expose it to users. How do you do that? And that's what first bucket was about. First bucket, we could spin up virtual machines. We learned about security. We learned about cloud functions. We learned about Docker and containers. So we spend a lot of time on that because that's the first, like, how do you actually get people to use it? For people to use it, you have to expose it to somebody, right? So to the world. We looked at some of the concepts. We didn't completely look at, for example, authentication and authorization so that the right person actually gets to use your tool and talk to your model. So we skipped a lot of things, but we also covered the basic patterns in which you can deploy. Okay, Flask was a canonical web framework we use, but we can use there are many others, and I think in one of the lectures we also saw Fast API and Django, and there are a few others. Okay, and just in Python, and there are obviously in other languages and many others. That was the first bucket. Now that took quite a few lectures, I think 4 lectures or something. So the next bucket is model lifecycle management, where we spend some time on version control. And although it's not exactly listed in that order here, we picked the versioning, second bullet point, versioning, and we talked about Git, because code versioning is 95% of the time that developers and data scientists also spend, even if you are a SQL DB analyst. So you spend a lot of time on just writing queries or writing ETL steps. So there's a lot of code version control that happens day to day if you are in this line of work. And then there's a bunch which is about model versioning. We saw MLflow as an example for that last time, and we also saw data versioning towards the end of last lecture. Data versioning is just it's nothing different from neither models nor data is any different from code. At the end of the day, they're all bits and bytes on the computer. It's just a question of how do you control when you snapshot them. Okay, so they're not fundamentally different, but the tools that we use for code version control, generally Git, or there are others, SVN and Mercurial and some other ones, but they all have this pattern of, once you are reasonably satisfied at some state of the code, it's working, or some situation, or debug with some bug fix, then you kind of explicitly snapshot it, and with comments, so that you can roll back to that working stage. If you want to roll back. Okay, that's on code. Model is exactly like every time you run a training script, tools like MLflow will automatically log all the parameters, all the loss curve values, as well as the artifacts like confusion matrices and the model weights themselves. They can be logged. And then the last one was data version, which is really not different from model weights, because with data, it's just a question of, if you had a table of 1 million rows and now you have to add another 200,000 rows, then you just want to know which run corresponded to which data set. Okay, so some signature of the data is logged using a tool such as DVC. Those were the 3 things we saw last couple of lectures on versioning. So code, model, and data. Okay, so today we'll look at scheduling, and we may not have time for A/B testing, but I'll briefly mention it. So the remaining tools, I'll briefly mention it towards the end if we run out of time. But the remaining ones are, I'll briefly mention them, but the third bucket is about big data, which there is a course for it. So thankfully, it's not a skipped topic. It's a required course for at least MSBA students. So if you are, you will take it at some point. Oh, it's not a required course. Oh, it's an elective. Okay. Okay. Yeah. So that course covers how to split whatever job you're doing, whether it's training or whether it's data processing, how to split it beyond a single computer, because single computer is already very good, actually. But at some point, you want to kind of rely on multiple computers. Then how do you do that? And that's the state of affairs with all modern, companies who have large volumes of data. They have to kind of work with distributed situations, okay, big data situations. There's some tools there. Some of them are actually replacements for pandas. So pandas is a very popular library for data frame, creating a data frame object and slicing and dicing data, right? So there's a tool called Dask or a package called Dask, which lets you kind of, which is a kind of a replacement for pandas if you want to split across machines. The last two buckets, streaming is something we'll probably not get the chance to cover in this semester, but it's a very different idea of thinking of multiple programs potentially living on different computers, and each one passing data or messages. Like if it computes something, let's say vectors, it passes to some other program. That program uses the vectors to compute, let's say, nearest neighbor, and then processes some other program, and so on. So it's a architecture where you don't think of data lying on a database and then some compute going on it, but really moving version of the data view. Okay, you think of the system like that way. So one of the popular softwares is Kafka. There is a information in the repository for how to get started with Kafka, but I would say just go to Kafka's website and you can try out the quick start. And lastly, the last bucket was tools of the trade. This is where I think even from the first lecture, I was heavily emphasizing on an IDE. But you could use an IDE. You could just use a Jupyter's native interface on the web. Git is something we covered. And modern Python, we did not get a chance to cover much of it, but maybe towards the end, I'll just show the different concerns. Okay. Related to types and other things. But so that's where we are. These are just selected popular topics related to MLOps. Now today, so the next few minutes, what we're going to do is just really focus on scheduling, because it's a easy enough concept, and we just want to see what are some tools and how do we schedule things. Okay. Any questions here? Okay. Okay, so let's actually. Yeah, so this is what we did last time, versioning. So code versioning, model versioning, and data versioning. So model versioning, actually another popular model versioning or model tracking, experiment tracking, training tracking software is called Weights and Biases. It's a very popular one. So we didn't see it here, but that's something if you're interested in. It really hooks well into your workflow, and so you should see how they have figured out what's the right product to kind of help ML scientists and data scientists to build their models. The data versioning, we saw DVC, but there are others, other ways. So let's skip that MLflow stuff. So next, what we'll look at is scheduling. Okay? So scheduling is a very fundamental aspect of computing. So there's a lot of scheduled processes that run on your typical computer. For example, Windows update, right? So Windows update, for example, or Mac update, or even Linux update, it gets triggered every 24 hours or every week to ensure that the software you're running has no vulnerabilities. Okay, vulnerabilities are generally considered bad, where adversarial actors can try to infiltrate into organizations' networks or whatnot. So we have a course on cybersecurity if you want to take it. But all I'm saying is scheduling is an inherent part of computing. Okay, you don't have to. So whenever you have tasks, think of tasks as like, okay, an extraction task or a transformation task or a training task or something else. You don't have to immediately run it. You don't have to manually run it, right? So you can always defer the running of these tasks to pre-specified times or some periodic fashion, some frequency. Okay, so for example, this slide, we're just saying, okay, there's an ETL task that needs to run, then a model training task that needs to run, and then maybe the trained model, is used with test data to kind of generate some predictions that are pre-saved in a database. Okay, and this is a very common pattern in ML services, which is, I know in the first bucket we saw how to expose your model directly to the world or whoever is the user, but many times what happens is exposing the model versus exposing the predictions of the model. Exposing the predictions of a model is easier because it's just predictions are just going to be numbers or maybe a vector, and so they're just easy to store as like in a database, like a MongoDB or a Postgres or whatever, in some application database, and it's easier to expose a application database because they're by default accessible from different clients and different locations. Whereas if you want to expose a model, you have to take care of you have to wrap it up in a Flask or something else, right? Some other web framework. So there are a lot of these types of tasks which need to be repeatedly run, and for that there are actually several tools to help you do that. Okay, on the smallest scale is a tool called cron, which is actually developed in 1975. Okay, so it's 49 years old by this point. So maybe 2 times the average age of the audience here, but nonetheless, so the smallest tool, which is cron, which we'll just quickly do a demo today, it's available in most Linux systems, including Mac, and obviously in WSL2 as well. So cron is a tool that works for scheduling things on a single machine. So it's mostly a local thing because of its historical origins. And then there's a tool called Airflow, which is a Python-based tool. It's just an example of a scheduling tool, really focused on data pipelines. And so really data science related tasks are generally scheduled on something like that. And then Airflow is an open source tool, and it has managed services, just like many of the other tools that we've seen. So managed services on Google Cloud, for example, it's called Cloud Composer. It's exactly Airflow, but managed by Google, at least the management of this tool, so that you just focus on your tasks. Same thing with another company called Astronomer. So they're all just vendors for this tool called Airflow. And Airflow is not the only tool. There are many, many ways to schedule things. So we'll kind of do a quick run of cron and Airflow today to get a feel for what they are. Okay. So let's do cron first. So actually, we have a cron example, but it really, it's not really, I think in the cron example folder, there's a very minimal set of instructions of how to run a job. So a job or a task, I'm just using the words informally. So what do you want to do, right? So it's very easy to schedule a job as a user, even a user. You don't even have to be a root, root or an administrator to run these types of things. So first of all, let's talk about the use cases, right? I'm talking about a tool, but like, what are the use cases, right? For what would be a use case for you? You can periodically ping a website and say, oh, the website, maybe you're looking for tickets for a concert or something. You can periodically ping a website, or more for data science stuff. Maybe you're scraping a website, maybe you're getting prices. So prices from a grocer, let's say Trader Joe's or something, and you're getting prices every day. It's just to know that how the prices vary over time. And so you're getting a dump of basically item and price, like a 1,000-row table every day. So you can get that table and then upload it into a database, or just save it as a CSV file. So you can run this again and again and again on a periodic schedule. Okay, so that's the typical use cases to kind of, for this tool, for a simple toy examples, those are the 2 illustrative examples. So how do you do that, right? So as a user, and you can do it as a root as well. It's a little bit slightly different flow, but a very simple way to use it is to cron tab. Cron tab is the program to So cron tab is a program that's generally available in Linux systems as well as in Mac, also Windows subsystem for Linux. So cron tab -E is the way to get to a file, which is just a text file where you specify what is the program you want to run and when do you want to run it. That's it. So what is scheduling, right? You just want to know, you don't want to run the program now. You want to defer it to some future time. And the question is, what is the name of the program? Where is it located? And when do you want to run? Okay. That's what scheduling is, right? So cron tab minus E just opens a text file, and E stands for editor, so just a text file. So generally, that's the preferred way to open this tool, because that's it's just historical origins. It's a pretty old and mature tool that a lot of folks used historically in this way. So this is just an editor. Okay, so I have my cursor going up and down. That's because the editor is a text-based editor. So it actually gives you this, when you open this file, it also gives you a bunch of comments. So with anything that starts with this hash is a comment, it tells you how to schedule something. So you can read this line, right? So for example, if you want to run a backup of something, of user accounts on your machine, let's say every user has like /home/Teja or something like that, then there is and if you want to run it at a specific time, like 5 a.m. every week. Okay. So this is the first 5 characters, which are generally numbers with a space between them, with some star and numbers, that kind of specifies the schedule at when do you want to run this program, and what is the program you're running. It's a program called tar. It's like zip. Okay, on Windows you have WinZip and other tools. Tar is a program that also lets you create a zip file for a bunch of files. Okay, so it's just this long string is a program with some arguments. Okay, so anyway, let's come back to our. So now I'm in an editing mode of this text editor. So if you want to get to editing mode for this editor, so I've used Vim, VIM is the name of the program. But you can use any editor, okay? As long as you know how to navigate up and down and make edits, it's fine. So it says here, right? So month, hour, DOM means day of the month. Actually, there is a helper website. I mean, there are many helper websites like this. So crontab.guru tells you what how do what is an expression you want to have when you want to run this, right? So minute, hour, day of the month, and then month, and then day of the week. Okay. So what do we have here? Yeah, day of the month itself, and day of the week. So those are the 5. Sorry, at the very bottom I have this cursor: month, minute, hour, day of the month, and day of the week. Okay, so that's the specification. So you can see that here 05 means 0th minute of the 5th hour, so 5 a.m. Star means I'm not specifying whether which day of the month or month itself. So it's just every month, every day of the week, if possible. And then 1 means which day of the week, the first day of the week. Maybe it's a Sunday or Monday, whatever is the convention here. So it's just saying every week, run it at 5 a.m., a backup job. Okay. So this backup location doesn't have to be just here, right? So you can say backup to an S3 bucket or some cloud location so that you have a backup of your data. Or if you think of an application database like a Postgres database, there's a tool called pgdump. Instead of tar command here, you could say pgdump. Okay, dump your databases and get the basically your database data, and then push it to S3. You can just have you can have a program like this. Oh, sorry, you can have a schedule like this. Okay. So just to kind of wrap up the demo, let's actually run the example that's written in the text file here. So it's saying insert the following lines. Okay, it's saying local machine, but if you want to run something every minute, okay, if you put 5 stars like this, then you can run something every minute, and you can check that here, right? So 5th minute of the 4th hour every single day is when this thing will be run. But if you put a star and a star, it's saying every minute. So every minute run something. So we'll just do that and wrap up this demo. So let's go back. Yeah. So we put 5 stars here, and then a space and a command. So for us, what is the command? So let me open another terminal. So with IDE, you can just press the plus command to get to the terminal again. Okay, so second terminal. So I want to see. Okay, so I have a file called run this job.sh. Okay, so let's actually see what this job is. It's just saying, okay, write the date and put it in a folder called date job every minute. Oh, sorry, put it in a file called date job every minute. So it's just, so I have a very trivial job or task. It's just saying get the date. Date is a program actually. Actually, you can see it here. So if I type date, you get some string. Okay, so date is a program that's available locally, but you could change that to anything. pgdump, tar. You could be also like, making a request to a website and scraping it, right? So you can write your Python script and you can just call the Python script. So, and then this two arrows here, this greater than, or yeah, this greater than less than symbols, they just mean redirect the output to a text file. Okay, so on the text file, I'm just putting in some location, but actually we can just put it in this location. PWD stands for print current directory. So let's actually copy this. And yeah, I'm just putting it in the directory where I have this run this job or something. So just so that everything is self-contained here. So what we're going to do is run this job.sh is in this directory. And that's what we're going to tell crontab. So crontab will say, now we're in the other terminal. It's just going to focus on saying that, hey, run this program, which is / run this job.sh. Okay, so that was the name of the file. So we're just saying, okay, at this location, there's this script, which is a simple script. You could have a Python script there, but just for simplicity, I have a script with a ending .sh. It's very equivalent to Python. It's called a shell script, but it's not important for us. We could have just written a Python script saying, okay, save the date to a text file. Okay. In fact, we could do that using ChatGPT or whatever they are, Google, the autopilot, Copilot, sorry, but we'll not do that. So this is the edit, okay? Just one line we added, and then we save, okay? In Vim, it's a :wq will get you the saving, will save the file. Okay? So now you can see there is suddenly a file just appeared, date job every minute. Okay, so you can actually click on it. So it already ran once, and every time it's, every minute you're going to see that it's going to get updated with a new line at the bottom. Any questions about cron here?
Can you do it in seconds in terms of minutes?
No, highest resolution is minutes for this program. Yeah. I think seconds is too fast, but yeah, I don't know. Yeah.
Something like trading needs.
No, these are scheduled jobs, right? So scheduled jobs, if you want, so for example, although this is a resolution of minute, in your program, in my shell file, or it could be Python file, you could have a sleep for 100 milliseconds and then run like something else, sleep for 100 milliseconds, run something else. You could do something more, right? This is just at the, yeah, I mean, the system level limitation, but you can always in your program have a querying thing every 100 milliseconds or every second if you want. Yeah. So you could have 60 entries instead of a single entry, right? I mean, I'm using the program date, but you could, in Python, you have time module, so you can do time.now or something appropriate, and you can print it like many times, right? Yeah. Any questions online? Or okay, so we'll leave this running for now. So next we'll look at Airflow. So before getting into, so this tool is just a simple way to get a sense of what is that, what is the frequency you want to run. So it has an interesting, yeah, you can just, for example, if you pick a random choice, then saying 5th minute of midnight, after midnight, in the 8th month of the year. Okay, so it's just the interpretation of like, so that the computer understands what you want, what do you like, what is that you, when do you want to run it? Okay. So with that, let's actually skip over to the next tool. Cron, although it's good, it's very easy to kind of understand like when to schedule things. It's only restricted to a single machine. I mean, in the sense that there has to be some key machine, like a master or some sort of key machine, which can trigger a program inside the program, maybe in a py file or something. You could have all sorts of complexity. You could be triggering something in a different machine and so on. But the restriction is it's kind of the keys to kind of triggering everything is like has to be this text file, okay, which is a little bit limiting. So the other end of the tool, it's called Apache Airflow. Apache is just name of the organization, which kind of incubates this open source project called Airflow. By the way, Airflow is a tool from Airbnb from 2015. So about 9 years ago, Airbnb developed that tool and they open sourced that tool. And then a software organization called Apache kind of took it on and incubated it. Okay. So Apache is also, its claim to fame is there used to be a web server called Apache Server, which used to be serving, which is still used for serving websites, okay, in general. So let's actually look at Airflow. So before I get into the Airflow's page, I just want to mention one new idea. Okay, so still scheduling of various things, various tasks. But now our view of how to think of these tasks is not going to be tasks in isolation. Like we said, okay, you can have a program that triggers many things behind the scenes, but to have full visibility, you want to think of tasks as nodes and then arrows connecting them as dependencies between tasks. And in general, the full bigger workflow pipeline would be, you would think in terms of a directed acyclic graph. Okay? So just in terms of a graph where nodes are basically the individual specific things that you want to do. And then the whole graph represents the full pipeline or the full workflow that you want to capture. Okay. So here you can see an example where you ingest data, you analyze, there's some automatic analysis of the data, checks the integrity of the data, like null values and whatnot. And then you report those integrities. If there's some challenges, then you trigger an email flow and it gets emailed to somebody's inbox. And then if there are no errors, you save it into a downstream location where it's further consumed by data scientists or whatnot, right? Or even an automated script. So this is an example of end-to-end workflow. And this can be represented using a cyclic graph. So acyclicity, or not having cycles, is kind of important because you can't have a task go back and lead to another task. So it cannot be in an infinite loop where one triggers the other and then the other one triggers this one and so on. So acyclicity is important, but this is a very nice abstraction, very nice view of thinking of jobs, okay? Collection of jobs. So what is Airflow, right? So Airflow is a much more complex beast, the complete other end of the spectrum compared to cron. So it has various things. Firstly, there is this directed acyclic graphs. Okay, so Airflow is Python, kind of very Python friendly tool. So first of all, it works with Python files. So in Py files, you would describe such a graph. Okay, how do you describe the graph? You can say, okay, function 1, function 2, function 3, function 4, and you just say, hey, function 1 precedes function 2, function 2 precedes like function 3 and 4 together. So you somehow you have to describe it, but it's all in Python. We'll see an example. Okay, that's at the bottom. So that's generally you would put in a folder or something in a appropriate location, which will have these Py files, which will describe these pipelines. Airflow is a multi-machine tool, so it can work with multiple machines and have full visibility into what's running, what's not running. Okay, very different from cron. Which means it has machines, which is on the left side, workers, which are, it's not necessary, but optionally, you can add explicit workers for these execution of these tasks inside the DAG. It also has a Flask-based web server. Okay, so it's exactly the Flask framework that we saw. It has a Flask-based web server for people to monitor what tasks are running, when they'll run, just like the text file. So text file is one UI, but it's very limited and prone to kind of editing and whatnot. A web-based UI, very similar to MLflow's UI. Okay, so it'll show, okay, what's the run, when did it run, did it succeed, did it fail, what happened? All those details are captured in the web server. And then it also has a database to capture all the metadata about these pipelines running, over days, and history of the pipelines and all the details. Okay, so this top one is generally a Postgres database, or it could be some other SQL type of DB. Okay, so that's the so it has a lot of moving parts, right? It has a Flask app server, it has a database, it has a directory of Py files which describe the DAGs, And then there is a scheduler plus executor combo. Scheduler is the one exactly like cron. It will say, okay, when to schedule a job, where to schedule it, and what to schedule, right? So what's the job, when to schedule, where to schedule. That's the job of this program. And it has, when something needs to be done, there is a appropriate executor, because this can run all sorts of heterogeneous types of jobs. It could be, which could be tool specific, like, hey, run a backup of Postgres, or run something on Snowflake, or run something on, Google Cloud Function. There are many different things that you can kind of the scheduler can schedule at an abstract level, and then executors actually help execute them on appropriate workers. Okay. So that's the overall architecture. Let's with that intro, let me actually, sorry. Okay, this is just the website for Apache Airflow. Yeah, I mean, its origins from Airbnb 9 years ago to now. It has evolved with a lot of contributors across the world, improving the tool and so on. So here they have different, marketing speak, right? So they have a lot of different use cases that they're thinking of. Scalability, dynamicity. So pipelines, these DAGs are defined in Python. So this can be, as I said, it's not a single machine thing like cron. And there are many. The reason why it's popular is because of these executions of various different types of jobs, and which might be involving other tools. Okay, so which is not, if you want to write something from scratch, if it has to talk to Google, if it has to talk to Google Docs, if it has to talk to an email, automation tool, like all those are for a separate. If you write it from scratch, it's going to be very hard. But they have, because of the momentum of the project, there's a lot of tools that are available. Okay, a lot of I guess functionalities that are available. So yeah, I mean, these are, I guess, very generic statements. So let's see, is there anything else I need to show? Okay, so this is the open source projects webpage, and they have their own documentation. We'll get to actually we'll look at the documentation in a second. Yeah. So yeah, we'll look at documentation, and we'll look at another vendor to kind of actually go through the demo. So what is, I said this is a pretty complex beast. It has it can run on multiple machines and all that. But at the end of the day, you have to specify your workflow, your pipeline, right? So that happens in a simple Python file. And this is an example of a workflow where you are pretty much describing a DAG, okay? A DAG with some ID and some start date and what is the schedule. This should be familiar. This is exactly like the cron type of a definition of when to schedule, when to run. So it's every minute, every hour. Sorry, every 0th minute of every 0th hour. So basically in a 24-hour period at midnight, basically run something. And what is that something? Here are the tasks, the nodes of your diagram. Like in the slides, we had like maybe 8 or 9 nodes, those specific things. Here is just a hello world task, one node. And that task is basically, so this is one task, which is called hello. So and the program that is going to run is called echo. I don't know if you've heard of the word program called echo. It is a simple program that's, again, very similar to echo is a program with just whatever argument you give, it just responds back the same argument. Okay, so it's just echoing whatever you said. So in this example, they said, okay, first node of my graph is just going to be this echo program. And that's why to run the echo program, echo runs on the command prompt. So you want to have like a bash. Bash is the name of like the shell language. So this is how you create one task. And the second task is a simple Python function. Okay, it's print something, Airflow, right? So these are 2 tasks. And in fact, the DAG here is a very simple DAG with 2 nodes. And it's just saying hello precedes Airflow. So first you run the hello task, then you run the Airflow task. And this is a looks strange notation, but it's basically saying hello first and then Airflow. If you had one more task, then you'd add like a double arrow and say, okay, task 2, and task 3, and task 4. This is one way to kind of define a sequence. And there are other, obviously it's not like a line, right? It cannot be a line graph that one task and then next task and next task. There could be parallel tasks going on, and much more richer tasks, right? This is just hello and Airflow, but you could have much more richer things going on, right? So, but all of them will be expressed in py files like this. So the UI looks like this. We'll just run the same thing in a second, but the Flask app, okay, I know we did a very simple Flask app, but this Flask app is pretty elaborate. It has a lot of drop-down menus and buttons and so on, but it actually shows you what the DAG looks like. So it actually has a UI for seeing what the DAG is. Here is a different DAG, which has a print date, a sleep, and something else. So this is one, you can see the DAG and when it ran, when it did not run, and all that. So that information is on the right side. We'll actually run it in a second and show. Actually here, yeah. So you can see, several times it ran, and in the future, I don't know what the light green means, but there is some notation for like, success of the jobs, failure of the jobs, and so on. Yeah, so I would encourage you to look at it. Um, okay, we're still here. Let's go to. Okay, I somehow am not landing at the right spot. Let's see. Yeah. So this is exactly Airflow, except it's managed by a, this vendor provides a managed service for Airflow. So let's actually go through their quick start tutorial. But they have very interesting, like, you can go through their documentation. They're nicely laid out. If you don't know anything about Airflow, they'll talk about what is Airflow, and exactly the same. It's not exactly the same, but said in their words, but what is Airflow and what use cases it has, and so on. So let's directly go to quick start. And okay, not this. Yeah, I think I went to a different quick start, which is using the managed service. But so the prerequisites are Astro CLI and then Docker. So Astro CLI is something that you can install from here. So I have already installed it. So I'm not gonna, it's basically just go to the install the CLI, and there's a command for both Mac, Windows, and all three platforms. It just gives you a command. You can run it. And then we're gonna start a project. Okay, so these guys arrange things in a nice way so that everything is self-contained in a folder, so that if you want to just delete things, you can just get rid of it, and everything is Dockerized. Everything is in a container, and again, same idea, so that things don't spread out over your host machine, so you can easily kind of remove them as needed. So yeah, I'm just creating a different directory called Airflow Astro example. Oh, that's not the right. Sorry, that was just my firewall. But I have an Astro CLI installed. Okay, it's a command line tool that's installed, and it is version 1.22. And let me go into the Airflow Astro example, and now I can type Astro dev in it as the tutorial says. And now what's happened is it has created a bunch of files. Okay, so in this folder, oh, we're still running the date job. Okay, so we can actually stop it. So the way to job, stop the job is obviously you want to get rid of this job. So I just committed it off so that now it doesn't write anymore. Okay. Let's not worry about this. So if you look at the Airflow folder, it has created a bunch of files here, folders and files. So in particular, there's a Docker file. There's a README, which tells you how this folder came about and so on. So it has a bunch of folders. Just to give you a sense of like what is it. So DAGs, which is exactly what Airflow needs. DAGs is a folder where you'll keep these py files which describe the pipelines. Okay, and there's a Docker file that's is specific to their tool, kind of working with Airflow. There are some additional files like requirements and package.txt for any extra things that you need. So after we do that, after we do that, before we execute the next command, I want to tell you what it creates, right? So remember, we wanted to kind of not just use Airflow, but this is like a complex tool demo where we're also using Docker. So this command astro dev start, it actually creates 4 containers. Okay, historically we were just creating one container, which is like a prediction model, is predicting, making a prediction, right? So that's what we've done, and we did see OpenFace and some other complexities related to containers. But when you run astro dev start, it actually spins up 4 containers on your machine. And what are those 4 containers? Exactly the same that we just discussed. A database for the metadata about all the jobs you're gonna capture, all the DAGs and when they were run and all that. A web server, which is exactly this Flask web server, which has a UI, where you can see the DAG and see all this metadata basically. The scheduler and the trigger, they are just considered as two separated containers. Okay, scheduler is the one which schedules, which tells you when to run the jobs, and trigger is basically for delayed jobs. Okay, jobs running in later, somebody has to kind of get them started. So there's something called a triggerer. But that's what those 4 containers get started when you run astro dev start. Okay, so let's actually run it and just see the UI. Okay, that's pretty much the end of the demo. We don't want to kind of do too much complex stuff here. So let's see Docker. We don't have any container running right now. So astro dev start. Exactly, we have seen this before where if there is no image, container image locally to you, then it goes to a remote registry like Docker Hub or some other place, downloads the image in this case. You can see all the download that's happening. And once the image is downloaded, then Docker, the service, lets you create a container of it. And that's what we are going to look at. So this might take a few minutes. But in the meantime, any questions from anybody? Let me just see if there's people online are available. Yeah. Any questions about this tool while we get this running? What we'll do is just get the 4 containers running and just see the UI, because there's a default DAG in there. And actually, we can see the DAG here in the meantime. Okay. Okay, so while we, yeah, now it's downloading Postgres. So the 4 different containers means 4 different images. So it's downloading all that. So here is the example. Yeah, let's look at the DAG basic one. Right, so this is exactly the very similar to the example that we saw online, where this is an example of a simple DAG with 2 nodes, one after the other. Here, example of a different DAG with a lot of comments, but it's the same format. DAG, which is scheduled. So it's slightly different format here @daily. So these are things that are there in the Airflow documentation. When to start from the beginning of 2023 for oops. Okay, this popped up because this just finished. So let's just look at this. So it's running here at 8080, and that's what we opened. The Postgres this is a default port for Postgres. If you run a Postgres through Docker so that you don't mess up your rest of your system, then generally it runs at this port 5432. Airflow UI credentials admin, and Postgres DB are Postgres. So these are so let me just clear this. And then if I just do Docker PS, you can see the 4 containers now just started. Okay, one of them is Postgres, but the other ones are UI, the scheduler, and the trigger related. Okay? Which are behind the scene details. Let's look at this DAG and also in the UI. So what is this DAG doing, right? So this DAG has a couple of tasks. So a couple of things. Extract. Actually, let's do that in the UI so that's a little bit easier. So the username is admin. Okay. So there are 2 DAGs in that folder, and that's why 2 entries appeared in this UI. This is just a Flask app, but more elaborate. Okay. Right. So there are a couple of. So if you look at the there are 2 files, right? Example DAG basic and example DAG advanced. Those are the 2 lines here. Okay? Example DAG basic and advanced. You click on DAG basic, it gets into the details of what this DAG is about. So it apparently looks like there are 3 tasks. So if you actually look at the graph, which is just a visualization of this task, you can see that this has 3 tasks. Okay? In fact, instead of looking at the code in VS Code, we can actually look at the code right here. It's exactly the same thing. It just reads from the PY file and just displays it here. So the code has a very simple code. It's saying, this is a function decorator. We have seen this with Flask, where you can annotate a function with the function decorator. It's just a wrapper to that original function. Okay. So this is just a function decorator. It's a Python feature. So there's an extract function, which is like a task. It's just a demo, right? So here the extract function is just doing, if this is the collection of, if this is the string, I want to kind of make from that string to a JSON object, basically a dictionary, and return the dictionary. Right now it's a string, right? So you can see the 2 ports here. So there's just a string of dictionary, but dictionary is like literally a string here. Okay. So you want to make it into an actual dictionary object. So this is how you do it. JSON.load, a load string would load the string to a dictionary, create a dictionary from a string. And then you have a next task, which is a simple transform task, which is just looking at the values in the dictionary and then adding them up. And the last task, load, is just it's not really doing anything. It's just given an input, it's just printing it out. Okay, so it's a very simple boilerplate. I mean, very simple hello world type of activities. And yeah, and then here, either you can put arrows to kind of specify which order the tasks run, or you can just call the task, call the task like this in one order. If there is a more complex DAG dependency, then you have to use the arrow symbol or some other way to specify the order in which task needs to be done. So this is pretty much describing this graph. And now you can actually run it here. Yeah, so you can just click this trigger. So to manually trigger this DAG, but otherwise we have specified when they should be run, right? So we have specified that it should be run daily, and I don't know if if the time is not set. I think it defaults some default time like midnight or something. So if you just run it manually now, you should be able to see it running, and then you see that ran. And what the green means success. But if you messed up something, right? So for example, if I go to the code and change this to hello, right? So now this should not work. See, you can see that it may have issues. I mean, it's retrying things. So there's some details that we have missed in the specification. But if you look at the code, we change the hello, and actually there's a retry also. So you can retry twice. So it's failed once, and so it's retrying, and then later you'll see that it's going to be red. Yeah. No, but the scheduler doesn't know what the issue is, right? It could be various issues. Maybe network was suddenly dropped, like how I had with Zoom, right? So there are many issues because of which schedulers generally generally specify that schedulers should retry things. Yeah, so this one, I think retry is yeah, we can come back to this. I mean, we have not really looked into what's the frequency at which it will retry and all that. But this is what a scheduler is. So this is like, as you can see, it's not like cron. It's much more feature-rich tool, and that's why they're managed services. But it just kind of gives you a sense of this was actually created for data pipelines, and it has been now. I think it can go beyond that. You can actually have other types of activities, workflows. But this is how you. So this is the UI for it, but behind the scenes, there's workers, there's scheduler, there's triggerer, and there's also Postgres DB, which is storing all this information that the successful run when it happened, how much time it took, and all that. Any questions about this? No. Okay. If no questions, there's one last thing I wanted to quickly cover, which is called continuous integration and continuous deployment. It's a concept which builds on our version control stuff, which is what we saw in the past couple of lectures. It also builds on scheduling. Okay, scheduling is what we've seen, where you can run things at periodic times. So think of a code base, like you're writing. So let's say you have a validation data set. You've been training models, day in, day out. But you could have a scheduler schedule a validation job where every time, what is the latest model? Let's run it on this data set at every midnight. Okay, every midnight or every end of the week. That seems fine, but you can already see what there's some gap in what I said. You would ideally prefer that every time you ran your model and maybe committed that model related code to GitHub or some location, you immediately want to trigger a downstream task of validation and then reporting back some validation numbers. So what I'm trying to say is that that immediate triggering of a subsequent task is achieved through this notion of continuous integration. And then a more advanced version of it is called continuous deployment. Okay, integration is something that you might have heard of. It's a word that generally captures the idea that if developers are developing on features, or in general data scientists developing on new models, every time you commit something, every time you version something, then some downstream tasks immediately get triggered because you version. Somebody is watching that you are committing something to your Git or wherever, and whenever that commit happens, some downstream, machines are spin up, containers are spin up, validation data or something like that is loaded up, and some validation runs happen, and then whatever is the results, they get reported back in the same, like potentially in a pull request, okay, or some other location. So that's called continuous integration. And continuous deployment is where your whole company product is like automatically, every time new features are being built by developers and data scientists, whenever this continuous integration is successful, when tests all pass and everything like that, then that code is further deployed in production situation. Okay, there's no manual handholding of, oh, now the code is all clear in terms of QA and tests. Now let's actually replace the existing production code with this code. There's no manual intervention. It's a continuously updated code. Okay, that as I said, that is a more advanced thing, which most organizations would probably, unless they have maturity in continuous integration, it's not a, probably perhaps they should not reach out to that. So in that context, there's a tool which I wanted to show called CML. Okay, so this is just a tool, but this is not the only tool for continuous integration. But just to kind of wrap up the version control and scheduling story, and this is where we'll stop. So it'll just take 5 minutes to just show what this is. So it's a tool for, as it says here, right? So it's basically exactly does what we said. So every time you have a script which has like a logic regression, like a scikit-learn based logic regression model being trained, once you commit that code to GitHub, in this case, in this demo, which you're going to see next, the CML tool will automatically trigger a validation job and produce, like, for example, a confusion matrix, and then attach that snapshot to your pull request, for example. Okay. So let's do that, and then kind of break for today's demos, and also kind of summarize quickly. So let's actually get into this. By the way, this is mentioned in the slides. I didn't want to, I'm not saying something like completely out of the blue. Actually, maybe it's said in the first, yeah, if you see the versioning, I think in the subsequent slide I didn't mention, but CML is the tool that we are just seeing now. Okay, and we're seeing it now and not before is because we had to go through Git and GitHub a little bit to get feel for like version control first, and then we're looking at this. And in process, we'll also look at a new idea. At least GitHub looks at what are called GitHub actions. How do you implement continuous integration? There has to be somebody who's looking at your code. Every time you made a code commit or a pull request, somebody has to do that extra step of spinning up extra machines for doing that validation job or whatever it is, right? So GitHub, through its proprietary service called GitHub Actions, does that. It looks at your code. Somebody does a pull request. Oh, now the code is ready to be, let's validate the new model or something like that. So that's the context. Let me get back to CML. So yeah. So the way how is this instrumented, right? It's not, it's only instrumented through this notion of GitHub Actions. We'll not get into the details of GitHub Actions, but it's, as I said, it's a way for GitHub to watch your pull request. And whenever you make a pull request, you can trigger a downstream task. Okay? It's very similar to scheduling, but it's not scheduling at a fixed time. It's scheduling right after something happens. That's the key idea. And the way you specify it is like this. Like if there's a push event happens, if there's a pull request happens, then you can say, okay, let's trigger something. Here, here's the name of the job. It's called train and report. It's saying, okay, download a image, create a container, and check out the current code base. Okay, these are all very standard, so don't worry about like how this is specified. This is just first time seeing it. They may look a little bit new, but then it's just saying, okay, once you copied the current code base, which has the current code repo, I mean, current logic regression training model, then you pip install. Maybe there is requirements.txt, so maybe pip install whatever is the requirements, and then you run the training. So here is just an illustration, so it's rerunning the training with the latest code. And then whatever confusion matrix was generated, then just attach it and just kind of attach it and show it as a as an illustration in a comment. Okay, so that's how you would see it. Yeah, this part is just get the numbers. So this numbers, how are we getting it? It's from train.py has a way to kind of write a metrics.txt or something like that. We're just writing it into a report.markdown file, and then the plot is also generated by the train file, train.py. And so the metrics and the plot are just concatenated into a single markdown text file, and that text file is just attached back to the pull request. Okay, so I'm wondering if it's a. Let me just go here. Instead of running the whole thing, I can just show you what it is. So here is an example repository. This is not ours. I mean, this is the repository of the of CML's CML's developer. So you can see this is just a very simple repository. It's a repository with a train.py file, a requirements file. So if you look at the train, for example, it's just a simple scikit-learn random forest classifier. Okay? It's just a binary classifier that's being built. And what are we trying to do here is that if we choose the hyperparameters, maybe the random forest has a depth of 5 and 20 trees or whatnot. Given that specification of the model, what is this performance? Right? Held out performance. Instead of you doing it, every time you push the latest code, that will have the hyperparameters. And given the latest code, somebody, in this case, GitHub Actions, spins up a container, basically, and looks at what is the validation data, looks at creates the confusion matrix, and then spits it back as a comment. Okay. So instead of running this, I'll just discuss this. And the other files are all, it's just requirements.txt, and some other files are also logged here, metrics and plot. So the key thing is there's a folder called .github, within which there's a folder called workflows, within which that CML tool can be used. Okay, this tool works with GitHub as well as other vendors, Bitbucket and others that you saw on the main website. So this is exactly the thing that we saw in the CML's webpage. Okay, this is just a text description of when somebody makes a push, then let's just look at let's retrain the model, generate the plot, and attach it as a comment. Okay? So you can imagine all sorts of things that are happening. So every time a data scientist pushes a new model, a deep neural network, or a random forest model, some downstream checks and balances on held out data, data statistics, model statistics, all sorts of things can be reported automatically. Instead of some manually triggering, analysis jobs, you can do it automatically here. Okay, that's done here. Obviously, you have to say what is our, how do you do it? Automatic triggering happens through this. Yeah, so if you look at this, this was a PR. I'm trying to see where the if I click on any commit details, okay, I'm not seeing the okay, I'm not seeing the CML comments, but yeah, let me see which of these where the CML, because I have to go back and see how they actually when did they insert the workflow and when did the GitHub Actions took place. I need to just look around the repository, but you'll see a confusion matrix very similar to this, right? This is actually a screenshot from GitHub. You can see GitHub Actions bot commented on a certain commit, it just shows the what is the accuracy and what is the confusion matrix. Okay, you just need to see something like that in that repo. I'll take it out in a. Let's take a break for 10 minutes. I'll take it out in a second. But after the break, I'll also quickly summarize what we've seen today, and we'll stop there. Okay, so let's take a break for 10 minutes and resume at 4:37. 4:37. Okay, let's wrap up what we discussed over the past hour and a half. So basically, the last thing I was discussing right before the meeting, right before the break, was this CML tool. And I was trying to get it running during the break, but it looks like we are using the free resources of GitHub, and they have not yet allocated a virtual machine where it can run the job. So you can see that it started 6 minutes ago, and it's not yet. So basically, what it's doing is, so what we got it to do is get the job started, and once the job finishes, it's going to just attach that comment that you see in the CML's webpage. Okay, so how did we get there? I just copied the code. So I just forked. Forking means just copying in GitHub, but it's just think of it as like a copy in your repository in case you want to socially contribute. For example, you can make changes and then you can raise a pull request to the original code base, right? So what I did is I copied the code, the repository, and then I just made a comment. I made an update saying in the train.py file, I want to have the number of trees, sorry, not the number of trees, but the tree depth to be 4 instead of 5. Okay, that was a change. And with that change, I made a pull request. Again, I don't know why the internet is slow here. Yeah, so this was the pull request that I just made. Okay, it's just a merge request. There was a branch called Teja ML patch, and the file change was just a train.py file. You can see here where I just changed the depth from 5 to 4. So you do for this demonstration, you don't even need to go into command line or anything like that. I fork the code. That's just fork button on the top of that original repository, CML repository. I had a local copy. I just made an edit. You can make edits to files directly on GitHub also. You can use the edit button to edit the file. I just edited the file. That's it. And then it automatically told me, okay, do you want to save it in a branch instead of making an edit directly onto the main branch? I said, okay, make a branch. And then since I know we have a branch, it said, okay, do you want to merge that branch back to main now that you've made your changes? I said, yes. So that's what this pull request is about, just merging back that one change. And because we did that one change, it said, okay, pull request merged and closed. This part is not blocked by the GitHub Actions or this CI part, continuous integration part. But because we did that, that triggered a job. Okay, this job of validation and attaching that confusion matrix. So that job, how do we know this? Because if you go to actions, which is where it will show the jobs corresponding to the triggering thing. So it has listed that job here. So the job template here. How did this train my model come here? Is because in our repository, there's a .github folder within which under workflows, there's a text file. The text file is exactly this text file, this file that you see, not this one, sorry. Yeah, this text file, sorry. This text file here that you're seeing is in that folder. And that's how it's listed as the potential job here. So if you click on it, it's saying, okay, why did it get triggered? Because we made a pull request. You can see that merge pull request from some branch to the main thing. And so because that happened, we have queued a job. Obviously, you can click on the job. It's still probably, it's still queued. It hasn't executed. But if you come back to this after a few, because we are using free resources, it's probably not yet triggered. But if you are in an organization, if you have an enterprise account, these things get triggered immediately, not just for validation data, but it could be any source of tests. Okay, so general software engineering, there's a lot of tests that you need to run every time you have a feature, new development, new code. So those tests can, for example, be triggered through this. So it's just saying it's still requesting for a container to be spun up. That's okay. So that's about CI/CD. So, I mean, CD, we just made a remark. CI is also a very big topic within which we said CML is an example tool. And it just, the tool is just made for a little bit of like training and validation related tasks. Okay. So with that, let me go back to our, sorry. Let me go back to kind of recap what we did today, right? So let's come back here. So today we have been kind of in the second bucket. We started with cron. So obviously we kind of were talking about things before, which is about versioning, DVC a little bit, some comments about DVC and MLflow. But today's demos included cron, which is this bullet point here. And then we looked at Airflow. Airflow, we looked at through a vendor's tooling. It's called Astronomer, only because they use Docker as well. So it's a nice mix of those two. And then for versioning, we saw another tool, which makes sense, which also uses Docker, which uses scheduling, at least ideas from scheduling, and is related to version control of your training scripts, basically. But not just training scripts, but you can basically it's related to this notion of CI, continuous integration, which is a very big concept in software engineering. Okay. So continuous integration is something that's huge. And so the CML is an example tool in that respect. We did not look at A/B testing today. We did not look at big data in this course for this time. Which, as you guys pointed out, there is an elective course which looks into how to spread training and data manipulation, whatever data transformations across machines. There's also a new paradigm called streaming. It's not new, but it's an alternative paradigm of way to look at things, where each program has its own speed at which it works. And so there's a notion of queues and things getting buffered up. For example, if you're making predictions very slow, but there's a lot of requests for predictions coming up, they cannot be dropped, right? If you're busy, then you can't just drop the requests for prediction. So you have to queue them up. So all that is captured through the streaming idea. And there are appropriate software called Apache Kafka that also has its managed services, just like Airflow has managed services. Apache Kafka has a managed service in AWS called Kinesis. If you've heard of Apache Kinesis, Amazon Kinesis. So there's tools there, but we have not looked at it. So this bullet point also we've not seen. Streaming. The last thing is the tools. We have seen VS Code a little bit. We have seen Git a little bit in previous sessions. We have not seen modern Python ideas like types. Environments we have seen already. Virtual, and we have seen virtual environments is one way of doing content. I would say self-contained projects. And MyPy and Flake are just extra tools that I wanted to briefly mention without getting into any details. What are they, right? So these are by default can be enabled in your IDE. So Flake, what is Flake, right? It's a style enforcement tool of your Python code. So Flake, it's called linting. That's a technical term for this type of a tool. It basically ensures that your code is conforming to a set of coding guidelines that are either determined by Python community or determined by your organization. Okay, so if your organization says, hey, you cannot write, you cannot write list comprehensions, okay, in Python. So you remember, like you can put square brackets and you can say X for X and X. So let's say your organization forbids writing list comprehensions. So Flake8 will ensure that if you try to write list comprehensions, it will say error in your IDE. Okay. So it's mostly for ensuring some styling guidelines are met. Otherwise, if multiple people work on the same Python code base, it'll look like a huge mess, right? Somebody will write a long variable name, somebody will write IJ as variable names. So to kind of avoid that, there's this is one tool to enforce the styling requirement. Similarly, it's very related to another tool called Black. So these two tools can be enabled in the IDE. So in your VS Code, you can check by default. You can just even search for them, and you will see whether it's enabled or not. So another tool is called Black. It's a code formatter. So for example, if your statement, let's say there's a statement in your Python file which is like really long. So every time you save your file, black is one of the programs that can execute and say, oh, there's a really long line. Let me format it so that it actually fits within the screen, for example, automatically. So this more like a code formatter. It also has a style guide. Like Google, for example, recommends that you should not have statements more than 80 characters width or something like that. So it also, so both work in tandem and have some overlapping responsibilities, but one is linting, one is styling. Okay, so Flake8 for linting. Linting is like really no like list comprehensions. That's not really a style thing. It's more, sorry, that's not really a code style thing, code format thing. It's really a rule that you should not be using, like pointers, for example, in C++, or something like that, right? So some rules. So that's what that's what Flake8 and Black are. There are other options there. And lastly, one related to a new feature, new Python feature called types, is this notion of static typing or type checking. So through a tool called MyPy. MyPy is a tool. What does it do? It's a static type checker. What does it mean? Okay. So every time you encounter error in Python, it's only when you run the program. Okay. So let's say your function needed a list as an input, but you only gave a scalar as an input. Okay. When do you catch that error? You run the program and maybe you see that okay, you're trying to find iterate over that scalar and then you hit an error. You can't, list is not, sorry, scalar is not iterable or something like that. But if you use types are just explicitly saying what the, so let me just zoom in here. Types are explicitly stating what is the input, what is the output for type of the. So for example, here you can say Fibonacci fib n versus, that's the old style. I mean, that's a more beginner level style, writing of a function. Here fib n colon int means, okay, n is supposed to be an integer. Okay, so this is something you write when you write your Python program, and the output is an iterator, which is also a iterator of the type int. Okay, so these are some explicit specific things that you're writing explicitly in your Python program. Okay, now what is the advantage of writing this more verbose second version that is here is that when you write this, then there is a program called MyPy that can run, that can just read your file. Okay, there's no running of your Python file. You can just read your file and say, hey, there is an error because if you're expecting int, and later on if I use fib on a list as an input, later on if I call it, sorry, in my program, if I just write fib bracket with input as like a list, MyPy will throw an error. Okay?
When will it start working next?
It will not run. What's it?
Then how will it work?
Every time you save, for example, or every time you save or make a commit or something like that. Yeah, you can. So these are programs. All these programs are either at save or at push. One of these commit like checkpoints. Okay, so these extra tools are like mostly checkpoints. Yeah. So what is static type checking, right? So it's basically checking the integrity, getting rid of bugs in the program without running the program. Okay, and this makes sense for programs which require which are strongly typed, like C++, Java. You have to say explicitly what the input type is and what the output type is. But in Python, just put a variable name, but it could be a list, it could be an integer, whatever, right? So they lead to massive amount of bugs, especially in large code bases. And so to avoid that, you can take advantage of types, and then a program like this, which statically type checks your code. Okay, so just wanted to mention these three things. We don't have time to cover, but it's good to know. It's my So that's what listed here, like some modern Python ideas. And last, I don't want to spend again time on this, but the last tool is testing. Okay, so I know we said A/B testing. We don't have time to cover. If we had one more lecture, we could have covered testing and A/B testing. But A/B testing is more detailed, so I will not talk about it at all. But testing is something that's integral. Testing is integral for software engineering in general. It's also integral for us as in data scientists and business analysts. So for example, if you do pandas operations, you want to, for example, ensure that the number of rows that, after you did some filtering operation, the number of rows is gone, should not be 0, for example, right? So you can write a simple, you don't have to use this PyTest module, which is a example module for testing Python scripts or Python programs. you can just use assertions, right? In your code, you can say assert number of, length of the list is greater than 0. So if it happens that for some reason, for some bad processing, the list became an empty list, then you know that program should end there, like it should error out, right? So that those types of things you can do by default. PyTest is an extra really nice module that a lot of projects use, open source, as well as a lot of companies use for writing a bunch of tests, okay, which can call a function and say, oh, is the function actually behaving the way you intended to? For example, if it's the Fibonacci series, Fibonacci number generator function, then it should generate exactly, that the next number should be the sum of the previous two numbers. That property should hold. So you can write a bunch of test cases so that they actually, the function conforms to those cases. Okay? So that there is no error being introduced every time you do feature engine, new feature development and stuff like that. So PyTest is a very, very easy to kind of set up in a program, and many projects that you'll see, Python-based projects in GitHub and Bitbucket and whatnot, they would have something related to testing. Okay? It's a very integral part. We have not discussed it here, but worth knowing about. It shows an example of if there is an error, shows where the error is, and so that you can go back and fix it and so on. Okay, and now these tests can also be triggered using the CI pipeline. So every time you make a push or a commit, let's say you are an unknown developer contributing to an open source project, the open source project's maintainer will have a GitHub workflow, this type of GitHub action, which when you make a pull request, it automatically triggers the tests. And if the tests don't pass, they'll say, hey, first you kind of need to ensure that your code is not messing up the existing code, right? Once you pass this test, maybe then you can look at features and code styling and all that. And then if it all works out, then you actually merge it back as a feature into a popular project. Okay. With that, let me just really wrap up. So today we saw cron, Airflow, and CML as 3 tools. We briefly mentioned MyPy, Flake, Black, and PyTest, but those are just examples of very few examples of many, many tools that you can use to improve workflows in ML lifecycle. Okay, so with that, we'll end the discussion of tools for today. You can stay back and ask me questions about the tools that we saw, or you can ask me questions about the project. And I will send an email with the box link where you upload your slides, and also some commentary on like how long the presentation should be. Okay, that I'll send during the week. So if any questions about this, okay. If not, let me pause the